All right, so we are in for lesson 6 of subtopic lines and vectors. So what you're looking at is finding equation of a line. Case 1. Now, case 1 means, like, so for example, in a certain year, an examiner may decide to bring a question from here. Or if you check in the question bank, you realize that there will be a question similar to this. That's what we mean by case. A case means that an examiner who may be setting the paper may choose in this heading and sets a question of this type. And we have in lines, we have over 3 cases of how to find equation of a line. The first one is given any 2 points on a line. An example we have is find the vector and parametric. This was meant to be find the vector comma parametric. Find the vector comma parametric and the Cartesian equation of a line passing through points A and B. Okay, like that. So here we're going to say simply, shall we say, solution. But what do you know about equation of a line? Please, I will say recall. Don't forget this. Recall. Don't forget that our line is small r is equal to A plus lambda mu, whereby this mu is the parallel vector got after subtracting b minus a. This is the point on the line, and this is r. So therefore, we shall say, from r vector is equal to that plus lambda mu. Please, all you need is to memorize this formula here. So lambda mu. But how do we get mu? Remember, from here, if this is a, it means that OA is the same as A and is the same as this. Same as 1, negative 1, 5. Then it also means that OB is the same as vector B and is equal to 1, negative, sorry, is equal to 4, 0, and 5. Please take note of that. OA is the same as small A, OB is the same as small b. So now, but mu, our mu is equal to B vector minus A. That's what we mean. So therefore, I will substitute. And I will say R is equal to R vector A. R vector A is 1, negative 1, and 5, like that, plus lambda. Now we're going to subtract B minus A. Where is the B? Before 0 and 5, like that. Minus A, which is 1, negative 1, and 5. So it will be our final answer. Our final answer will be R is equal to a 1, negative 1, 5, plus lambda. 4 minus 1 will be a 3. 0 minus minus 1 will be a 1. A 5 minus, is that a 5 minus 5? No. This is negative 4, 0, negative 1. This is 4, 0, negative 1, please. 4, 0. Okay. Then also a negative 1. They are like that. So 4, 0, negative 1. So here, at the end point, we shall have a 5 minus minus 1, which will definitely give us a what? A 6, like that. Now that one there, the one we have at hand is a vector equation. Is a vector equation of a line. You already have it, like we are. Now what next do they want? They want a parametric equation. So parametric equation. So parametric equation. Parametric equation would be, now our R is a general point which we call the x, y, z. Is a general point called the x, y, z is equal to 1, negative 1, 5, plus lambda 3, 1, 6, plus lambda 3, 1, 6. Now this will imply that x from here, x is equal to 1 plus 3 lambda, that is equation number 1. Then y is equal to negative 1 plus lambda. Of course, negative 1 plus lambda times 1 is lambda, is equation 2. Then z is equal to a 5 plus 6 lambda, that is our equation number 3. And now those ones are our parametric equations. Parametric means they just make the values of x, make this the subject equal to that, the middle one equal to that. Then, okay. Then lastly, let's see Cartesian. Cartesian equation. Cartesian equation, what do we do? Now, Cartesian equation, make lambda the subject. 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 So this will now be making lambda the subject from equation 1. Lambda will be equal to, from equation 1, make lambda the subject is equal to x minus 1 over 3, comma. In equation 2, lambda will be equal to y plus 1 over 1. Okay. Make lambda the subject in equation 2 will be z minus 5 over 6, sorry. Lambda is equal to z minus 5 over 6. That's what we have. Now, to get a Cartesian equation, lambda is equal to that, lambda is equal to this, lambda is equal to that. So what you do, you equate this equal to that and equal to that. So therefore, we shall have x minus 1 over 3 is equal to a y plus 1 over 1 is also equal to a z minus 5 over 6. And now that is our Cartesian equation. So please, in order to save time, I'm only doing one example, but you can also look out for more questions. This is always the logic. So for case 1, done. Let's now move on to case number 2, or the next case. All right, good. So we have another example. Here. So you're saying find the vector, comma, parametric and Cartesian equation of a line. But still, under finding the equation of a line, we are now dealing with case 2. The other one was case 1. Case 2, when given 3 points on a line. So 3 points on a line have this, this, and that. Solution. So now shall say, from writing equation of a line, from R equals to okay, vector A plus lambda mu, like that. Now here what you do, you choose 2 points with which you're going to subtract. Then the remaining one will be the point on a line. So we know that your mu is equal to, now your mu means the parallel vector is subtracted. You can choose any you want, or any of your choice, or we can sample all of them. You can take that mu is equal to b minus a, like that. Try that and we see. B minus a is 6 negative 2, 5. Then also minus, right. A is 2, 4, 1. What shall we get? 6 minus 2. 6 minus 2 will be a minus 8. Then a minus 2 minus that will be a negative 6. A minus 5 minus this will be a 4. Like that. Then also sample. Mu is equal to that b minus, rather, you have said b minus a. Now what if we try c minus a? A is a point on a line. We are taking a to be the point on a line, please. That is a point on a line, is what we are subtracting. So it will be c is 6, 7, negative 1 minus, right? A is a 2, a 4, and a 1. They should be the same. So this will give you 6 minus 2, give you 4. 7 minus 4 will give you 3. Negative 1 minus negative that will give you negative 2. Now, after subtracting, what you do here is subtract the b minus a and even the c minus a. Minus a minus a, b minus a, then you compare. So comparing, you realize that comparing, allow me to do it from here. Let's look at this bracket. When you factorize out to a 2, what will you get? Here we shall get, okay, when you factorize out negative 2, you get here 4, here you get 3, then here you get negative 2. I think that this one, 4, 3, negative 2, 4, 3, negative 2 is the same as this? Yes. Then it means that this one will be our parallel vector. It is the same. It will be the same as the mu over here after factorizing. That means that your point on the line is this A here. The A. So now therefore shall now say that R is equal to point is 2, 4, 1 plus lambda. Now what is the mu? The mu is 2, 4, 2, 4, negative 2. Because we said that for parallel vectors, they must be having that common factor after factorizing, and they're all the same. Whether this or this, they're all correct. If you get this always factorize out a common factor, the answer you get is what you transfer there. No problem. So you would even end here. You would even end here. After getting this, if you see that it can be factorized, then you factorize out the common factor and you take the final answer. Or you can try and error. You do both of them and you see the way forward. Okay, good. Now that is now our vector equation. Let's now Cartesian or parametric. So let's get for them the parametric equation. So parametric equation shall say the R, so from R is equal to, a2, 4, and 1 plus lambda, okay, a2, 4, negative 2, like that. So now the R is x, y, z, a general point, x, y, z, and is equal to a2, 4, and 1 plus lambda, a2, 4, negative 2. Oh, right. So now, but we say that for parametric, we make x the subject, so x is equal to 2 plus 2 lambda. This is your equation number 1. Y is equal to 4 plus 4 lambda. That is your equation number 2. Okay? Z is equal to 1 minus 2 lambda. That is your equation number 3. And now those are the my Cartesian equation. That are the parametric equations. Okay, let's go by a Cartesian. Cartesian, I clarified in the other lesson. Okay, in the previous example, you make lambda the subject. So making lambda the subject from up there, make lambda the subject from equation 1, lambda will be equal to x minus 2 over 2, comma, y minus 4 over 4, sorry. Lambda is equal to y minus 4 over 4, comma, right? Lambda is equal to z minus 1 over negative 2. Like that. Since lambda is equal to lambda and is equal to lambda, you take this equal to that. So you have this x minus 2 over 2 is equal to a y minus 4 over 4 and is equal to a z minus 1 over negative 2. And that is what they wanted. All right, good. Let's still move on. Let us still move on. All right, so great. We now have another example. Oh, it is case 3, by the way. Yeah, it is case 3. Case 3, the last case as far as equation of a line is concerned. Given a point on a line and a parallel vector. So now they're saying, find the vector, parametric, and Cartesian equation of a line passing through a point, 2 in the I minus 3 in the j plus 1 in the k, and parallel to 4 in the I plus 3 in the j minus 5 in the k. So solution. This one is the simplest. You just say that, just memorize this. Equation of a line is always that in your head. Then it will be vector A plus lambda mu. Now this mu here is a parallel vector. You all remember that from the previous lessons. This one is a point on the line. So therefore, the point on the line is this one. Point on the line is this one. So realize that with this, maybe I just show you a little bit. Your vector A is 2, negative 3, and 1. Now your mu, the parallel vector, generally, no need to subtract, it will be 4, 3, negative 5. Please, here knowing the science and the terminology is used, puts you there. And the answer is done. What shall we do? R, vector is equal to, point on the line is 2, negative 3, 1, plus lambda. What is our mu? A 4, 3, negative 5. That is the equation of a line. Given a point and a parallel vector. Parallel vector is the mu. You just substitute. No need to waste time. Okay, let's go via parametric. Let's go via parametric equation. Okay, good. Now parametric, we shall just say, direct the R becomes x, y, z. The R becomes x, y, z, so you shall have a 2, negative 3, 1, plus lambda 4, 3, negative 5. Now here it will be x is equal to 2 plus 4 lambda. This is equation 1. Y is equal to negative 3 plus 3 lambda. This is my equation 2. Z finally is equal to 1 minus 5 lambda. That is equation 3. That is parametric. Now let's get the Cartesian equation. Getting the Cartesian equation here is simple. Make lambda the subject. From equation 1, lambda will be equal to x minus 2 over 4, comma, lambda is also equal to, here, this crosses here to be a y plus 3 over 3, comma, make lambda the subject here to be z minus 1 over negative 5. Sorry. Lambda is equal to z minus 1 over negative 5, like that. Now to get the Cartesian equation, you simply equate. So now this will be x minus 2 over 4 is equal to y plus 3 over 3, and is also equal to a z minus 1 over a negative 5. That's now our Cartesian equation. Yes, we are still proceeding. All right, so now let's look at this example where they're saying, another example is that, show that a point lies on a line. Now, to show that a point lies on a line, we simply, we say here, we substitute a given point in a vector equation of a line. Then we substitute that point in a vector equation of a line. Then, if we obtain consistent or similar values of lambda, then we can say the point lies on a line. So you substitute that point in the vector equation of a line, then when you see that the value of lambda is the same, you conclude that the point lies on a line. Example, show that the following points lie on a line. The line is R, 1 in the I plus 1 in the J plus 1 in the K, plus lambda negative 3 in the I plus 2 in the J plus 5 in the K. Now we want to show that this point lies on that line. Here what we see, the value of lambda must be the same or similar. So Roman number 1, the point, the 7, negative 3, okay, negative 3 and negative 7. So now this point you already name it x, y, and z. Now shall say from r is equal to, now r is write like this, you know very well, lambda, like that. Now what is that? It is 1, 1, 1. Then this side is negative 3, 2, and 4. You must be knowing how to write from an IJK format. Now, where the position of r is where I put this guy. So position of r, 7, negative 3, negative 7 is equal to 1, 1, 1 plus lambda, right, negative 3, 2, 4. Very good. Then let's start equating. I'm going to be equating them from here. The one up will give us that the 7 is equal to 1 plus, 1 minus, this time this will be minus 3 lambda. Let's get the value of lambda here. This will be now 7 minus 1 is equal to negative 3 lambda. This will give us a 6 is equal to negative 3 lambda. Divide by negative 3, divide by negative 3. Let's find that now your lambda will be equal to negative 2. Okay, lambda is negative 2 for that first part. And let's come and see in the middle here. Negative 3 is equal to 1 plus 2 lambda. That's what we do. Correct like terms is negative 3 minus 1 is equal to 2 lambda. Divide by 2, divide by 2. We realize that your lambda will be what? So negative 3 minus 4 minus 1 will be negative 4, divided by 2 will be negative 2. Oh, like we are. This is the same, this is the same. We pray when the last one may be also the same. So negative 7 is equal to 1 plus 4 lambda. So be negative 7 minus 1 is equal to 4 lambda. Divide by 4, divide by 4. So lambda will be what? Negative 7 minus 1 will be negative 8. Divide by 4 will be negative 2. Like we are. They are the same. Now we say since the value of lambda is the same, the value of lambda is the same, comma, then the point lies on a line. Then the point lies on a line, as simple as that. So you will also try out this one here. You will also try out that one there and see how it comes about. It should give you the same values of lambda. As simple as that. All right, so let's proceed again. We have more examples. Please, this is all very important. They're saying express the following in vector form. Express the following in vector form. Remember, vector form must be in this order. Vector form must be in this order. This is Cartesian. This is Cartesian. Then parametric is done whereby I have x is equal to something, y is equal to something, z equal to something. So this one is Cartesian. Back to the vector. So now we shall say solution. Solution. Now what you must know is, R is equal to vector A plus lambda mu. Lambda mu. Now, this one is here. This mu here is the values in the denominator. The denominators gives you that mu. Then this A here is the, say, equate. The A you get from equate numerator to 0 to get that A. And that is all. So now we shall say, but before you do that, say coefficients. This is very important. Coefficients of x, y, z must be 1 before you do this. Must be positive 1. Please take note of that. And let's check. Coefficient of x is positive 1, positive z. Then I can do the needful. So now R vector will be equal to, here you equate denominators to 0 plus lambda. Here you put denominators. Denominator of x is 3, denominator of y is 1, denominator of z is negative 2. In that order, finished. Now here equate numerators to 0. So x minus 1 equal to 0. So x minus 1 equals to 0. So x minus 1 equals to 0. What will you get? You'll get that x is equal to 1. That's the logic you're using. So here I have a 1. Equate y to 0, it will go the other side to become a 1. Equate to 0, it will become a negative 3. And with that, you're finished. Write what you call a Cartesian, rather a vector equation. It is as simple as that. Okay. Back here again. Here we are. So now we shall say that R is equal to, we have learned from that example, plus lambda. We have learned from that example. For this, equate numerator to 0. X minus plus 1 equal to 0, negative 1. This will be, now, you have to be careful. The next value, the values must be in this order. It must be x value, y value, and z value. But look, here we are having y is this side. So y is equal to 4. Then put here just 4 direct. All right. And then z, numerator, this one. When it is like this, written in this format, y is equal to 4. Of course, you just take y as 4. Then z plus 4 equal to 0 will be negative 4. Okay. Now, problems are here. The lambda is the denominators. Here, the one for this is negative 2. The one for, now this one is z, but here we need y. Are you saying a denominator on y? When you see that is written as y is equal to this without a denominator, you always put a 0. Please take note of that. Then lastly, the value of z is 4. Don't get confused. This is x, z, y, but it's meant to be x, y, z. That is how we do it. Now part C, they're saying x plus 1 over 3 is equal to negative y plus 1 over 4. Z minus 4 over 5. Now, we only pick, or we only get the Cartesian, the vector equation when the coefficients of x, y, z are positive 1. Positive 1, yes. This is negative 1. Now trouble. We don't need to pick. What do you do? What do you do? Solution. You come and make sure this one becomes a what? A positive. So how will you do it? So this one will be x plus 1 over 3 is equal to, I'll put it in bracket, negative 1 plus 1 over 4 is equal to a z minus 4 over 5. Now, to remove this negative, you multiply by negative 1 up and even negative 1 down. Because that's what we do to harmonize this area in order for it to become a positive. Multiply by negative 1 up, negative 1 down. So this will now be x plus 1 over 3 is equal to, now negative 1 times y will be y minus 1 over negative 4 is equal to a z minus 4 over 5. Yep. And with that, we can easily write our equation just here. So R is equal to R plus lambda. Yes. These are denominators. I'll pick direct, negative 4 and 5. Then here, numerators, equal to 0, negative 1, equal to 0, 1, equal to 0, 4. And that is your vector equation. All right, great. So let's see, also look at this. Express the following in Cartesian form. Express the following in Cartesian form. Now this one is in vector form. We want to take it into Cartesian. But of course, we shall now say solution. Don't forget that from R is equal to A plus lambda mu. Okay, this one was our denominator. From the other work, and this one was, this one is a bit simple. Okay. Now what we're going to do, we shall say, in the vector form, this will be solution. So now you start by x, y, z is equal to, can I bring that 1, 2, 1, plus lambda. Okay, it will be 2, 1, 2, like that. Then we need the Cartesian equation. Now I'll start with the numerators. First of all, I will say this is equal to, that is equal to that. I think that's how our Cartesian appears. This is the denominator. Denominator 2, 1, and 2. Because you see that these ones here are the denominators. If you rewind back the video, we are back working. These ones are denominators, so it's 2, 1, that in that order. So now let's see what are we going to put up this side. Up this side, you go and take this side. So 1 crosses the equal sign to be now x. There is x weighting, there is y weighting, there is z weighting. So when this one goes to find where x is, to be x minus 1. When this 2 goes to find where y is, to be y minus 2. When this 1 goes to find where z is, to be z minus 1. And hence that is our Cartesian equation. Okay, good. Now let's move on. So here still, this r in our solution, that r I shall call it x, y, z, and is equal to negative 1, 4, 2, all right, plus lambda 4, 0, 7. Now, where you see a 0 here, a 0 means no denominator. That's what a 0 means, no denominator. All right. So now let's conclude. Let's write that equation here. What will be our equation? First of all, we have this equals to, we have that. Okay, now you see that if it has no denominator, then we go by the ones which have, now this one no denominator, so this one has a denominator, this one has a denominator. So I'll begin with the ones with the denominators. Except for example, this one is, okay, maybe, but, okay, yeah, so what I do, I begin with those denominators. They have this x here, it is 4 down, denominator is a 4 because it is there as a digit. Now when this, okay, I have here x. Now when this 1 goes to find the x there, it will be x plus 1 equals to, now whichever one has a denominator, it is this. Now I know this one is there, I meant to go to y, but I don't have that is denominator, it is a 0. So I got the ones which you have so far. So here it will be 7, but we make a follow up. This will be z minus, of course, z minus 2. Now after that, those who have denominators after writing them, just put a comma, then you say who is remaining. We have x, z. So y is remaining. So y is equal to what? The value which is there. Y is equal to, okay, there is this. Y is equal to 4. Because the denominator was not there, so y is equal to 4. That's how we write it. I hope it is clear there. Okay, here also, solution. The one without denominator, we make it to be the last one. So here we are, still shall say, x, y, z is equal to, okay, 4, negative 1, negative 3, plus lambda 0, negative 2, 1. Okay. Now here, like we are, I want us to write. Remember, it has to be this equals to that, comma, because no denominator. So x is dead. Let me go to y. So y is what? Denominator is negative 2. And here I have y. This negative 1 crosses the equal sign to be y plus 1. Next, I will go to what? This one has a denominator, I'll make this one last. So now this one will be z, okay, plus 3. but over what? Over 1. Now the one without a denominator is x is equal to, so x is equal to a 4. Thank you very much. Make sure you subscribe to the channel.